properly. So maybe just about 30 minutes of discussion maximum, and may help you to move faster in the class. So as we have decided on, one day will be doing metrology laboratory and another will be metrology laboratory. And as discussed with Shobodip today, probably Monday will be difficult for me to meet with you online. So if everything is okay with me, then before Tuesday stuff, we'll meet on Sunday uh, during this time in the evening. There is the time. So am I audible to all of you?
Yes, sir.
So I will request Pramodip to share experiment number 2 in metrology laboratory. And already I have shared with him the different links that we prepared during the corona time actually. There was no offline, even the practical classes as you know. So online classes was there completely. Yeah. So one particular first experiment, if you recall, the experiment was one outside method was given to you, and I think you have gone for its calibration using the standard slip gauges. And slip gauges is an example of end standard. End standard and line standard. I think you do you know the difference between the end standard and the line standard. End standard and what is line standard? Example of line standard is you say the graduated scale that you are using from your childhood. Right? You are taking the measurement in between two engraved lines, but when you are taking the measurement between two end faces, that becomes the end standard. So end standard that you have used in your calibration experiment, it was the state of slip gauges. That was there in the outside micrometer of the calibration. And here in this experiment number 2, one particular job will be given to you. That is called the taper ring gauge, and the taper ring gauge is a job which will be having inside taper, and you'll be asked to find out the inside taper. First thing you should know as a mechanical engineer, what is taper? Taper, I think you might have drawn in your drawing class. Am I correct, Shobodhi?
Yes, sir.
So can you, if it is gradual decrease or increase as you see the job, maybe it can be cylindrical job, or if it is a rectangular shape, you can think of some wedge, right? So your the dimension goes on decreasing or increasing depending on from which direction you are looking into it. Now, supposing there is a cylindrical job and you have won it from taper, and the one diameter, the large end diameter is capital D, and the small end diameter is small d. So you know the taper usually expressed. You can find out the taper in two ways. If it is it can be expressed in TPI. If it is TPI or TPF, you know, thread per feet or thread per inch. So sorry, I mean taper per inch or TPI is also the abbreviation for thread per inch. So by mistake, I was spelling thread per inch. It is basically now here it is not thread, it is taper per inch or taper per feet, TPF or TPI. It is nothing but the difference between the large in diameter and the small in diameter. Capital D minus small d measured over a length of say 1 inch or 1 feet. Got my point. So basically this difference per feet or per inch. So that is express one way of expressing the taper. But the question, and also you can find out taper in terms of angle. An angle measurement you can get in two ways. Either you can find out the angle in one side taper with the center line of the job, right, and or the total included angle that you can get. So this calculation I am coming to you, fine. But first, you can you tell me any application of taper in mechanical engineering as you were in third year?
Sir, in
Well,
quarter joint,
spotted joint, yes, spotted joint. Any machine tool, Deepan? Any machine tool? Any
machine
machine tool application? Machine tool, I think you have started doing your work in the machine shop now, offline class. Anything you have done in the machine shop, do at machine shop? Has it started?
Yes, sir. Started, but we only last day we only studied about the lake.
Okay. So, but theoretically, you might have studied the lathe construction. The construction of lathe, as you know, probably there are two centers: life center and the dead center. Okay, so If you take the example of the dead center, if you take it out, you will see that's an application of taper is there. Taper is basically that taper is the external taper. Now, the hole where it is entering into also is kind of tapered socket into which it is entering, right? So taper in machine tool helps you in different way. Okay, so taper is used in the machines to hold and to align different component part like the center as you recall in your lathe. You might have studied the milling machine. Arbor is there. Have you studied milling machine in the machine tool class? Do you know milling machine? Term? Do you know the milling machine is there? Theoretical class. Have you done milling machine? Upon Shobodip?
No, sir, I can't recall. We have done that.
You have not done. Okay. So milling
We
machine
have
probably will be taught about the milling machine in the machine technology and metallurgy class. Milling machine is also another important machine tool. Just like lathe is also important machine tool, milling machine is also important machine tool. And in using the milling machine, most important component part that you can prepare, that you can manufacture in what is called gears, right? Gears you can manufacture in the milling machine. So one of the very slow method though, but it's a process by which you can manufacture gears. So in the milling machine there is an arbor, right? Arbor is there, ARBOR. So arbor is basically kind of support on which your milling cutter will be used to cut the gear. So that arbor is again the end of the arbors, it will be kind of tapered, and by which using that you can immediately insert it on the milling machine. So another example is the drilling. So as the word drilling is there, you might have come across the drilling machine in the fitting shop probably. In the fitting shop, I think you have drilled some hole. Have you done anything? But I think fitting shop was online, I guess, in the first year. Probably. So, but drilling is as the word implies. Drilling means you can well guess. Drilling is basically for making any hole. Now, the drilling by which the cutting tool that is used in drilling is called twist drilling. Now, the twist drill shank is there. Twist drill shank is having taper. Just I'm telling you some application. So, to twist drill, when we will be using in the drilling machine, first it has to be fitted in the twist drill shank having some taper, and that shank along with the twist drill will enter into the one particular place in the drilling machine. So it says it implies that you can immediately attach or you can hold the cutting tool, you can take it out, right? So you can hold the cutting tool, you can align it, you can even realign it when you are taking it out. So this kind of taper facilitates easy, the aligning or holding the tools as and when required in different machine tools. The lathe, the milling machine, the drilling machine, the different applications of tapers are there. So as I told you in the class, the mechanical engineering industry problem, you can face thousands of questions. So please remember some applications of the tapers. Also, you please take note of this. You please prepare the types of tapers. There are different types of tapers. You may get this in the engineering drawing book or in the internet source, or I do not know whether you have bought in a book. Different tapers are there. Mostly in the machine tool, the Morse taper is used. This after the name of the scientist, the Morse taper is being used in the machine tool in a big way. But so many other tapers are there. Jarno taper, Jacob taper. So how they are, the specified. Mostly the taper means some our bigger diameter, small diameter will be given if it is a cylindrical one, and the standard taper angle or the taper is a TPI, that is taper per inch or taper per feet, will be given to you. So that table will give you how many tapers are there in that size. So Morse taper, Jarno taper, Jacob taper. Please see the classification of the tapers and where it is being used in which machine tool. And also, most importantly, in the taper, before you go to the measurement, what are the other things that you should look into in the taper? I think that also should be discussed in the class. In the meantime, there are different taper turning methods in lathe. Have you studied that in machine tool, Shomodip?
no, no.
Report. There are different taper turning methods are there. The method that we'll be using also actually in the machine shop is the swiveling the compound rest then offsetting your tailstock, then also the taper turning attachment using form tool. So depending on the size of the taper, there are different methods available which you can adopt as per your requirement. So these are the issues which you should prepare along with the taper measurements. So that will be helpful for you in the future different exam on the Viva. Where taper is used, how taper is classified, how taper is made, right? What is the application, and how taper turning methods, different methods are there. Now this coming to your lab class here, you see the before you go to the calculation part, there is one correction you need to do here. The H3 value is not shown correctly. Each one H2 H3 you here. H3 should see the H3 and H2 are looking to be same, right? H3 you should take over the ball, over the upper ball. Okay, over the upper ball. So the first thing is that before you just think of the ball, before you place any balls, the two lines indicate the round job given to you. Okay, so if you take the sectional views, the hatch line is there. So suppose you have not put any balls inside, so you see that two portion of the hatch lines using hatch lines, so that indicates the section view of the taper linkage given to you for finding the taper measurement. So what you do first, you place your job in the surface plate. You might have seen in your metrology laboratory, okay, and take its measurement. That measurement is see here, H2. H2 is the measurement, height H2. So H2 measurement, you have to use the vernier height gauge. So this thing you should remember. What are the instrument required? How to use the vernier? Any vernier instrument has got the procedure reading like what is called the main scale reading and the vernier scale coinciding, and into the vernier cost give you the vernier scale reading. Then each one is the measurement. What you have to do, you have to take your job on your hand and then allow the smaller ball to go inside. Do not just throw the ball. Do not allow the gravity to fall. What you do, you just make it slight slope, right? Make some angle on your and allow it to roll inside. If you allow it to fall from the top, what will happen? Due to wedge effect, it may go further below, giving some erroneous results. So better that you should allow the slow movement of the smaller ball inside the job, and then you keep the job in vertical position. Then you take the measurement H1. This H1 measurement is very important. You put a star mark there. H1 measurement, you have to take the measurement using what is called depth micrometer. At least you know this thing, depth micrometer. Depth micrometer, depth micrometer is very, very important. You put a star there also. You put a just circle it, this depth micrometer. Depth micrometer is or micrometer depth gauge also sometimes it is being called. Depth micrometer and outside micrometer is having some differences. In outside micrometer, how did you take the reading? You took the reading MS reading plus CS reading into LC. Probably this is the reading. Main scale reading plus circular scale reading into the list count. But here, what you have to take, you must take into consideration the extended, small dimension extended bar will be attached at the front end of the micrometer. So extended length of the rod attached plus main scale reading plus circular scale reading into LC will be the final reading of the depth micrometer. Because why you need to take it? Because as you feel that each one is as you have to take inside the job and over the small ball. Okay, so that will be touched by that extended small rod fitted with the micrometer. So you do not forget to add that. Students often fail to add that when being asked in the Viva that what is the reading at this position. They take the MS reading plus CS reading into LC, but they fail to consider the extended length that is being attached with the micrometer so that you can cover the whole depth inside of the ball instead of this given job. And this is the one difference with the regular micrometer. Another difference is that the depth micrometer is graduated in the backward direction. It is the reverse direction, right? Reverse direction. It is not starting like 0, 5, 10 and not in this way. You start from say 25, then 20, 15. So it's in descending order. Why can you guess why it is so? Because I'm not giving you time to think over. I think you can find it out. It is given in the gradual direction and in the reverse direction for the simple reason. As you rotate the thimble over the sleeve, what will happen? Your extended rod will go much inside, right? As you come down, the depth increases. As you go up, the depth decreases. So that is the reason why the the dilution in the reverse direction, reverse order. Shobhit, is it clear, Deepak, what I am telling?
Yes.
Can anyone please repeat what I have told about the depth micrometer? What is the difference? Who can repeat, please? Depth micrometer and outside micrometer. What is the difference? I'm telling. Who can repeat? You are not listening anything. Who can repeat? In the depth micrometer, dilution in the reverse direction, number one. Second one is that one extended rod will be attached at the end of the micrometer, at the front end of the micrometer. This will go inside the hole. So when you take the final measurement, extended rod dimension plus main scale reading plus hyperscale reading into this count, this is the difference. Okay. And so the graduation in the reverse direction and the extended rod dimension you have to consider. Another important thing is that probably I will show in the class itself, that whenever you take the main scale reading, that is very vital. There is one index line. About the index line, some graduations are there. But beneath that line, suppose the graduation is in the interval of 1 millimeter. Beneath that line, graduation is in the interval of 0.5 millimeter each. So when you take the measurement, consider the graduations beneath the index line. Otherwise, you do not get the original actual correct reading. Suppose in your eye you see the reading on the main scale is 12, 12. So actually you have to take 11.5. Suppose you see 11.5 straight away by your eyes, but actually you have to take 11. Because why? Because zero point 0.5 is the graduation beneath the index line. When I say 11.5, means it has just crossed over 11. So this will be more clear probably in the class. So this, but you remember that the graduation beneath the index line you have to consider, which is graduated half of the value, which is shown in the above the index line value. So in the above the index line, the graduation in the interval of 1 millimeter. Beneath the index line, the graduation in the interval of 0.5 millimeter. Please remember this. So this is the one important dimension you have to consider when you take the H1 value. So H1 is to H3. H2 you have to find out using vernier caliper. H1 you have to find out using the depth micrometer. H3 over the upper bone you have to use the vernier head gauge. So vernier, not vernier caliper. H2, H3 using vernier head gauge. H1 is using the depth micrometer. So please repeat this. Who will tell now? Who can tell that what I have told? Omodip, who will tell? Dipon.
So you have told the depth micrometer. What is its difference with the normal one that we take the extra?
Normal is outside. The Dipon outside micrometer.
Yes, outside micrometer. So that is we take its graduation. That is if 11.5 length we are taking, and we have to measure. So we will take 11 millimeter centimeter like that. So the 11 millimeter. Actually, I'm not clear about that unit. So that 11.5 or
Dipon, yes, what tell me please.
sir, then there is an extended diameter length. That
Extended small rod
yes,
is putting out of the micrometer face. Okay, so that you have to consider when you take the measurement.
that we have to consider along with MSR plus CSR.
Along with MS rating plus S rating into LC.
Yes.
And H2 and H3, what instrument is required? H2 and H3. For this, you have to use the vernier height gauge. Vernier height gauge for measurement of H2 and H3 for each one depth micrometer. Okay, and what are the other things? That once you have placed the job over the surface plate, take it on your hand, okay, and keep it in this kind of slow position. Allow the inside ball to go roll inside it gradually. Then you take the measurement of each one, and then over it after you have just kept it over the surface plate, then you put the larger ball over it, and it will come out of the top surface of the job, and that's why you see the height is more. So you correct this reading H3. Now the question is sin theta by 2. Theta by 2, this, as you see, one small angle is there. So what is that? That is the center line joining the centers, line joining the center, just right hand side. Do you see another line? There is another line joining the centers. Okay, right hand side. So that line is perpendicular actually. Should I draw in the drawing here, or quickly I will draw in the class board?
So can you repeat this once? This,
I'm telling that theta by 2 value, theta by 2, theta
yes.
by 2, do you see how it has been taken?
Sir,
Theta
is
by
it
2,
perpendicular to plane like that? Yes.
so this line, the line between the centers, line between one line is line between the two centers, right? Another line is just on the right hand side. That line is perpendicular.
Is perpendicular to the plane of the screen we are seeing.
No, not to the plane of the screen. Another line has gone from the center of the upper ball to the point where it is touching the surface of the jaw. Just let me try you got the more let me see it. I can draw it, then I will show you. Just allow me some time. Just to see whether you can see the screen here. Yes. Do you see it, Deepan? Do you see the screen? Do you see the board here?
Yes.
Yes, sir.
So here, this is the incentive. Okay, this is a job that you have to surface plate. There is a ball in there, small depth surface. Each one is in the depth micrometer. H2 height of the job using vernier height gauge. H3 using the vernier height gauge. Now what I'm telling, this line if you draw, then you draw this line which is touching the job. So right, this line indicates that it is the point where the ball has touched the surface of the gauge. And this line is perpendicular. This will be your theta by 2 line. That I'm telling.
Yes.
You have my point. Do you see it now? So I should take the figure picture for you. So we need to show it. Let's see this. It's not visible to you right now. Shobodip, I have sent to you. Just please see that.
Yes, sir, I've received.
Deepan, you please see that figure. That is clear. Deepan and Shobodip only responding, so you are likely to get 90% of the marks. Other boys are not doing anything. You should, if I told you, no, if you do not interact, no point. If you say that, sir, you come to the class and take it in the class, I don't mind. Shobodip, this is the, the attendance. Then I should, whatever you listen, then I will tell him that from the next day, no one will. Whenever I is available, I will take whatever, whether you listen anything or not, I don't know. And, but this is the position, no point, no? Out of 24 students, how many 24 or 22? Shobodip?
Yes. Sorry, sir.
How many students are there in your group? 24 or
22.
22?
22.
22. So 8 students are done, not there. Keep the record for unofficially so that I can see. Now you tell me, you please show that calculation, whether it's clear to you.
Yes, sir.
Please show me the calculation. Deepan, have you seen the theta by 2?
Yes, sir.
Now you see, now sin theta by 2 is opposite side by hypotenuse. That's why R1 minus R2 divided by C. Is it clear? First relationship, R1 minus R2 by C. Now see how we would find the C. C is the center distance between the two balls. How you find out the C? You see, first you have H3 minus R1. H3 minus R1 means H3, first you take the measurement of H3 minus R1. H3 minus R1 minus X. C is the center to center distance between the two balls. H3 minus R1 minus X. X is actually, X is, what is X? X is actually H2. Just I'm coming to H2 minus H1 minus H2 minus R1. H2 minus R1. If you take H2 minus R1, where you land into? You have to find out the value of C. C is in between two centers. So can you please draw it, Deepan, in your khata?
Sir, 1 minute. One.
H3 minus R1. H3 minus R1, you come to this point. H3 minus R1. H3 minus R1 minus X. X is from the surface plate to the center of the lower ball. H3 minus R1 minus X, if you H3 minus R1 minus X, if you consider X is probably from the surface plate up to the center of the smaller ball. Am I correct?
Sir, here H3 is shown from that upper surface of the job.
No. That you have to change that. I have told you. This is my mistake. But I have sent you the correct one.
Okay.
H3
Yes.
is actually from the top of the upper ball.
Yes.
You just tell me the second bracket value. H2 minus R1, second bracket value is X. X is nothing but from the bottom surface to the center of the smaller ball. That I am telling. Bottom surface is how much? Bottom surface is your H2. H2 minus H1, it's always plus R2. It's already H2 minus would be.
Sir, are you showing something in board?
No, I'm trying to calculate it first.
Oh,
That's correct. What is X value? So could you find it out? X value should be from the bottom of the from the surface to the center of the smaller ball. That X you find out. Whether that H is H2 minus H1 minus R2. H2 is for the top surface, H2 minus H1. It is clear, totally clear. Why it is taking so much time for you? Now I'm showing you here. See the screen. You guys are more expert in the mathematics. What is the problem? It's simple. This X is the, I'm telling from the bottom of the job to the center of the smaller ball. This X, how you can find out? H2 minus H1, H2 minus H1, okay? Minus H2 minus H1 minus R1, then only you can say. H1 minus, I don't know, minus R2 or what? This smaller ball is R2, I think. H2 minus H1 is which distance? H2 minus H1, you reach to the H2 minus H1, you get which dimension? H2 minus H1 is this one. This one is H2 minus H1. H2 minus H1. You further subtract this one, then only you get this one. Minus R2. That is the X value. So why it is taking so much time? Am I correct? Devon? Prabodip. H2 is the height of the jaw.
From the top. Yeah.
H2 minus H1. You reach to the top of the lower ball.
Yes.
Yes. This dimension is your H2 minus H1. But how much is this distance? You have to further come down.
Yes,
Minus R2.
radius minus radius.
That's the radius of the smaller ball, minus R2.
Yes.
That will give you the X value. But back one, because X is nothing but, if you do not subtract the X, then you cannot reach the C value. So either H3, H3 minus R1, H3 minus R1, okay, minus X, then only you will get this dimension. That's why X is nothing but H2 minus H1 minus R. That is right. You have to find out this indirect way. So this calculation, only thing you are not doing yourself. That's why it is taking time. But draw it properly. Should I draw this figure again, or you have understood it?
Understood, sir.
This calculation is not a big deal. So this simple calculation you please do. That means what is the now what value you require for the calculation part? Go to the next part. Pramodip.
Instruments.
Instrument surface plate over which you will place your job. Two balls will be given. If ball diameters are not there, then you have to find out the ball diameter using the vernier caliper. I think ball diameter will be given to you. Yes, probably. And then micrometer depth gauge, as I told you, also it is called depth micrometer. Micrometer depth gauge, you see this micrometer depth gauge figure, do you see? As I was telling that do you see the extended portion on the left hand side? Do you see the left-handed portion? The extended portion. There is a small bar on the left-hand side. This bar has to be added in the final reading. So the extended bar dimension plus escalating plus circumscripting into this count will give you the final reading. And only thing I will show you in the class that you have to consider the resolution beneath the index line. That you have to remember. If you see by your eye the value 12, that is you have to take the dimension which has just crossed is 11.5. If you see 11.5, then you have to take 11. If you see 11, then you take 10.5. That you have to remember very quickly. And the vernier height gauge, it looks like this. The vernier height gauge also will be given this instrument. Vernier height gauge will help you to find the measurement of H3 and H2. And another very common question sometimes you have been asked in the Viva, that if you see the, can you make it bigger a bit? That vernier height gauge, if you see that, if you make it bigger, this person is very sharp, right? So this sharpness is not required for your experiment. Show me the vernier height gauge. Where it is there. Show me the vernier height gauge, please. So if you see the sharp portion, this sharp portion is for, suppose at particular height you have to scribe a line. It is mainly used for marking operation. So for this part will not be used actually. This figure is not exactly the instrument that will be using in your laboratory. And on the another right hand side portion is also there, but this instrument is not showing that. So that right hand portion will be used for the measurement. You have to place your job over the base, but I think this portion also will be required, that sharp portion, to find out the measurement on over the ball is. Okay. So that may be required, but the sharp is mainly meant for if you need to mark a particular line, if you want to for the marking operation, the sharp is used. So these are few things to discuss with you and go to the next page. All the videos also I have sent just before you start your work. That video you please see if for those who are interested. And your marks will depend on your interest on. Place the object vertically on the surface plate as I told you already. Place a ball of diameter D2, that is a smaller ball, so it touches on the sides of the taper ball. It does not touch the surface plate. Okay, so as if you see the figure, it has not touched the mm, surface plate. It is just touching the sides of the taper only, and that is also important. Some portion of the ball is projected above on the top of the workplace. Which one is it? There's a ball diameter D1. Or okay. This one. Second para. So it touches the sides of the taper roll and does not touch the surface plate. Measure the depth taken by means of depth gauge. And I have told you. But when you place the ball, smaller ball, do not just allow it to fall by gravity. Gradually roll it inside. And then third para is regarding the how you will place the larger ball. And placing the larger ball, you take the height measurement H3 by into the vernier height gauge. Also the H2 measurement with the height gauge. Repeat with balls of other sizes if they give you. I do not think they will give you the other sizes. So one pair of balls will be given to you. Next page.
Observation.
Observations are there. There is the diameter H1, H2, H3. And then from that using that calculation you can find out the taper. Go to the next page.
Precaution.
Yes, you should first study. That I told you already. That if you see the second para, the ball gently lowered into the position. If the ball is allowed to drop at all, it will wedge in the taper and maybe several hundredths of a millimeter lower than the actual diameter. So it can give some erroneous reading. Okay, next page.
This is the last.
Okay, this is the last one. And I think if you show that printed page also, please.
Which page?
Printed pages or printed page, printed class,
Oh, right.
printed page.
Mm.
Yeah. First one. Some questions are there that you get in your.
I think this part is covered. Theory. Instrument it is covered. Procedure.
We already have discussed. These problems, these all the questions you will get in the. I told you to buy the book. I do not know whether you have bought that book or not. In the library, you should get it, but you should invest in books. I don't know how many of you are doing that. Metrology book by RKJ and edited by IC Gupta. That using that formula of the starting formula was there with the theta by 2. With some partial differentiation, you get this final expression.
This
And
equation.
yeah. So that is available. And in some year, I have seen so many years back actually. I don't know who is teaching your subject this time. Who is teaching you the theoretical subject this time?
SNM sir.
Shuman.
Shuman, yeah.
Shuman. So usually what I have seen, I am talking about the 10-15 years back, I have seen that some of the question that is there in the metrology lab, they used to reproduce it in the final semester exam in the theory because the subject is machine technology and metrology. So I can tell Shuman to put some question from this question to you. That he has to decide, but this you will get in the standard, any standard book, the reduction. Some parts of differentiation are there. And number 2A is the mechanical kilometer. If kilometer is there in the laboratory that you can see, kilometer is one particular or any internet source or book, you see that how you can use the kilometer for find out the paper angle directly. And 2B is how can addition and subtraction of angles can be carried out by angle gauge blocks. We have used in the past experiment slip gauges where the cross section was, the rectangular cross section is the plate type of things were there in the slip gauges. Angle gauge is nothing but this kind of wedge shape, right? Wedge shape. Wedge. I think you have seen the wedge, right? WDG. The wedge shape blocks are there. Suppose you want to build two angles. Suppose you need to build a 32.5 degree angle. So you take, for example, I'm telling you by the 30 degree one block you take. Over it you take 2.5 degree block and add it will get 32.5. So just to build the angular dimension, angle gauge blocks are used. Now to build the dimension, sometimes you need to add or sometimes you need to subtract. If you need to add, then you have to put in one particular direction. Directions are given on the block itself. Some angle directions are there. If you add, you have to place the two blocks in the several directions of one above the other. And if you want to subtract it, then the directions will be the opposite direction. So that is also there in the standard books. And then the question number 3 is the optical bevel, optical vernier bevel protractor. Protractor we have used them from your childhood. Protractor means some kind of graduated circular scale will be there. So bevel protractor. So how it look like? The protractor one blade is there, and when the scale is there, the two part is there. That is flexible. Each part is there. So directly you can maneuver the instrument and just looking to the scale, round scale, you can raise up the V groove angle, V block. V block you might have done in your, I think you will do it in the third year itself, machining a V block. So that V block, V angle can be directly found it, you can find it out using the universal optical vernier bevel protractor. So this protractor is actually giving you the direct reading, placing the instrument over the job, you can directly read it from the dial of the job, dial of the instrument. So these are the few things I think you should get in any standard books. So when you prepare your lab sheets, you should add all these things. So with this, I will wind up.
Okay.
So please assemble in time there, and if you are free, just like the other week, Shomadip, you can go there earlier. You can start because of the reason that we have finished the discussion. And please keep this record of attendance and send it
Yeah, sir, I have already sent you.
for my recorder.
Hmm.
So, and then that you discuss with me if you are free for 2:30, go there early so that you can finish it.
Right, sir.
Thank you very much. But unfortunately, only interaction I got from you and with you. But I request all of you that if you do not come forward, do not interact, do not open up